Hi guys. Today I want to talk about solubility rules. So we are not actually going to do anything in your notes packet today. You should have a little half sheet in your binder that looks like this. This is also printed in your notes packet. So if you want to I don't remember if the blanks are filled in there or not. You may want to double check that in your notes packet, but you'll definitely want to pull out this solubility rules sheet. So these solubility rules are something that you would have access to on the test. Obviously, when you're testing remotely, you may use other materials as well that I wouldn't typically allow you to do if you were testing in class, but that's just kind of a little advantage you get, I guess, when we're testing remotely. But solubility rules are something like the periodic table, like the ion sheet that I would always give you as a reference. So basically it tells you what compounds are soluble and what compounds are insoluble. Soluble means that they dissolve in water. Okay, some things dissolve in water, they mix up nicely in water, and those are soluble. Those compounds are considered to be aqueous compounds. And so when you see them, and we talked about these briefly before at the beginning of our unit, they are written with AQ in parentheses. That means it's aqueous, it dissolves in water. Things that don't dissolve in water are referred to as a precipitate. Okay, and that means it precipitates out of solution. It separates out and kind of, sometimes it may float to the top or it may sink to the bottom depending on the density of it, but it doesn't mix in the solution. And if we were in class, we would do a little lab on this. Unfortunately, with the number of cases in the community right now, we are not going to be able to come and do a lab on this week. But maybe if we get back in the near future, then we can sneak this lab in a little bit later on. So I want to go through some examples today, and we're going to identify these as either soluble or insoluble. Okay, and if they're soluble, we'll write them as aqueous. Okay, so the first one, magnesium hydroxide. When we look at these solubility rules, we always want to start at the top. Okay, so magnesium hydroxide, here's number one. So let's look at this first rule. Salts of alkali metals and ammonia are soluble. Okay, alkali metals, if you remember, are in the first column there. Those with a charge of +1. Magnesium is not an alkali metal, and we don't have ammonia there. So we can kind of cross through that one. We're not going to pay attention to that rule for this example. Okay, so let's read the next rule. Nitrate salts and chlorate salts are soluble. Okay, again, we don't have nitrate or chlorate salts here, so we're going to kind of ignore that rule. Okay, sulfate salts are soluble. That also doesn't apply to us. Chloride salts are soluble. That does not apply to magnesium hydroxide. Actually, this magnesium hydroxide should be written like this. Apologize for that. Most carbonates, phosphates, chromates, sulfides, and hydroxides are insoluble. Okay. Now, note here it says exceptions, compounds of the alkali metals and ammonia. So we don't have an alkali metal, we don't have an ammonia, so we are going to call this compound, sorry, I'm trying to erase some of my stuff so it don't get too messy here. We would call this insoluble, okay, due to rule number 5. All right. Magnesium hydroxide is insoluble because it's that hydroxide there, and it tells us it's insoluble. Let's look at the next one. Lithium sulfate. Okay. Lithium sulfate. So that doesn't affect rule 1, doesn't affect rule 2, but it does affect rule 3. Sulfate salts are soluble. We do have a few exceptions. The exceptions are lead, silver, mercury, barium, strontium, and calcium, which is not us. So we are going to say that this is soluble. So when we write lithium sulfate, we would write it as an aqueous solution. Okay? Let's look at the next one. Lead carbonate. Lead carbonate. Let me take some of this other stuff off here. Trying to not junk up my words too much where I can't read. Lead carbonate, number 3. Which of these applies to lead carbonate? Well, it's not an alkali metal. It's not a nitrate. It's not a sulfate. It's not a chloride. Here we go. Most carbonates, phosphates, chromates, sulfides, and hydroxides are insoluble. Now, we have some exceptions. The compounds of alkali metals and ammonia. Those don't apply to us, though. So we would say that lead carbonate is insoluble. Okay. The next one, silver chloride. So that doesn't apply to Rule 1 or 2 or 3, but it does apply to Rule 4. Chloride salts are soluble. Now, we have some exceptions. Exceptions, compounds of silver and some compounds of Hg and Pb. So, because this is a silver compound and it's an exception, that's going to make this insoluble. Okay? Insoluble. Let's look at one more together, the last one. Calcium acetate. Okay? The first one, alkali metal. Calcium's not an alkali metal. It's not a nitrate salt or a chlorate salt. Number 3, it's not a sulfate. Number 4, it's not a chloride. It's not a carbonate, a phosphate, a chromate, a sulfide, or a hydroxide for number 5. Let's look at Rule 6. A salt with an anion charge of -1. Well, if we look up acetate, acetate has a charge of -1. Okay? So we would say that this is soluble, and therefore we would label it as aqueous if we are writing it out. Okay? All a salt basically just means it's an ionic compound. You see that here and you see that here. It's an ionic compound. It has a positive charge and a negative charge. It has a cation and an anion. So we think of salt as table salt, as NaCl. That's what we know to be salt, which it also is a salt according to chemistry because it has that positively charged sodium and that negatively charged chlorine. But a salt in chemistry is a compound with 2 ions that will separate in water. Okay? When you put a salt in water, the sodium chloride, or the 2 ions in the salt, the cation and the anion, those break apart. Okay? When we put them in water, remember water is HOH. It's a positive and a negative. Okay? And so what happens if we had water and salt, it's kind of like a double displacement reaction. The positive is going to repair with this negative to form HCl, and this positive is going to repair with this negative to form NaOH. Those ions kind of repair up in that solution, okay? And that happens with all salts when you place them in water, okay? They break apart into the positive and the negative and cations and anions. So for your assignment today, it's a Google form, okay? And I'm going to give you compounds just like these. And you have a drop-down box. You'll identify them as either soluble or insoluble based on the rules, okay? Again, you always start at Rule 1 and move to Rule 6. Don't jump down to another rule. If you jump down here to like these anion rules down here at the bottom, then you could miss some of these things up here and some of these exceptions, okay? So always start at the top and work your way down. If y'all have any questions about those, let me know. You won't see your answers. You won't see how many you got right until I release that after everybody is finished, which will be Monday probably, since this isn't due until maybe Saturday. It's not due until Friday at midnight. So good luck with those. Let me know if you need any help. Y'all have a great day.